Welcome to the final video for Unit 3 Constructions. This is over Target 3C, how to construct an equilateral triangle, how to construct a square, and how to construct a regular hexagon. Equilateral triangle, square, and regular hexagon. Reminder that regular means equilateral and equiangular. So we don't have to use that term for equilateral triangle because by definition, equilateral triangle is also equiangular. All right, let's get started. Simplest construction yet. If you have a distance from A to B, make sure your compass is set to that same distance. Just check. And throw an arc out to one side of the segment so that it's equidistant from both B and A. That distance from B and A are identical to the distance from A to B. So therefore, we use our straight edge to connect the intersection of the arcs to both A and B. We end up with 3 congruent segments and an equilateral triangle. Let's skip the square for the moment and jump straight to the next easy construction, which is the regular hexagon. So we want to use AB now as the radius of a circle. And I want to construct my circle. It's easiest if you just turn the paper as opposed to try to manipulate the compass. When we do so, we move the compass around a lot. The radius changes. So I recommend just holding the compass and getting yourself a well-defined circle. Once you have your circle, place the point of your compass anywhere along the circumference. Without changing the radius, mark off an arc that intersects the circle in 2 places. Put the point of your compass on one of those intersections. This is how we make patterns. We're being consistent. We're using those same distances. Keep putting the point of your compass on the same intersection. Make sure that the arcs that you're seeing are hitting the same spot in the center. If you are, then your compass is not moving and you're being concise, precise. Make those arcs, and you'll have the beginning of a 6-petal design or your regular hexagon. Making the 6 vertices for the 6 intersections on the circumference will give us our hexagon. Now, it just so happens that each of these sides are the same length as a segment A to B. That is because a hexagon consists of 6 equilateral triangles. If we connect the center of the circle to every other vertex, you will get a cube. Cube consists of a rhombus in each of these 3 sections. I would say rhombi, but I'm not quite sure that's the plural for rhombuses. Rhombus, quadrilateral, where all 4 sides are congruent. If you divide these in half, you notice that you have your 6 equilateral triangles. Now take this a step further. You're on your way to constructing a ring of 12 cubes. So this is something I pulled up off of Pinterest, I think is where I found it, after searching geometric constructions or geometric designs. Finally, a square is not going to be as interesting necessarily, but it is difficult. The first step is the same step as constructing a perpendicular segment. Remember, a square starts off with a side, and then we need a perpendicular segment, a distance for another side, a perpendicular segment, distance per side. We'll close it off but you'll see how it goes. We'll take these consecutively, side, angle, side to start, and from there, it's a fairly simple finish with just distances. The first step is to extend the line segment of AB so that we can mark off equal distances from B with the compass. From those intersections, we'll go out an equal distance on one side, larger than this distance or longer than this distance from A to B. Be consistent and make sure you check to make sure your compass has not moved. It's still the same distance. Now our intersection here, connect that to B and you will get a perpendicular segment. Now that doesn't tell us how far out to go along B, but if we take this distance from A to B, remembering that all four sides of a square are congruent, go out that same distance here. We'll go out the same distance above A. We know that this side is going to be the same distance, so we can put our intersection there, or point the compass there at the intersection, mark off an equal distance there, and now you've defined your fourth vertex, and we just need to connect all four vertices. We constructed the AB, or actually AB was given. We constructed the perpendicular segment out of distance AB, distance AB, and distance AB. There's your square.